Again, the stuff we do today is quite a bit harder, so we want plenty of time to go over it. Questions on 252, problems you want to see work? None of them?
I don't understand how to do
Why?
it first, like.
Close the road, man.
First six?
Like, I
I used to do
didn't
it when this
understand
left
what we're
work.
supposed to be doing.
Thanks for that day. Not this many hours you do. Okay, then yeah. You didn't take a nap at 1 o'clock when you got home too. Yes, you did.
So we'll do number one. Have your calculators out so you can help me, because I don't know what I did with the comparables. Malachi is going to be watching closely since he hasn't been here a couple days. He wants to make sure he understands this.
Of course.
We want the probability that x is less than 170. First thing, and today it's going to be even more important than it was on these. These, it wasn't really that big a deal. But you see, when I did my work, I still did it. First thing I do every time, draw the little picture. Draw a little curve. It doesn't have to be anything special. Decide what you want. So on this one, I know I want the curve. That's a horrible curve. And it told us that the mean was 174. So that's right in the middle there, 174. And all I really put on there is 174, then I want 170 on there. So that's somewhere about in there. And I want everything less than 170. So I'm looking for that area to the right. If I'm looking for that area to the right, then I can just use the calculator. And all I'm going to put in, what I'm going to put in the calculator is the low limit and the high limit. The low limit, or actually we're going to put in the mu and the standard deviation too. Low limit, we're going to go negative 10,000. Somebody tell me if I'm doing this wrong. High limit, we want to go up to 170. And then the mu is 174. And the standard deviation was 20. Does that make sense to everybody so far?
Always negative 10.
Negative 10,000. If you're going all the way down this way, you just want some number that would be way down here.
Have you go all the way the other way? And then if you're going to the right, then.
Positive 10,000. And if you're between two things, then you just put in the low limit and the high limit. So negative 10,000 is just a random number. Don't let that confuse you. That's just a random number that I picked out so I know I have everything. You probably don't need to go anywhere near that far down, because when we're on this, remember, anything past 3 standard deviations is very unusual. So if we're at 174, 3 standard deviations, a standard deviation is 20. So if we go down 20, then another 20, then another 20, that's 60. We're down to take that minus 60, we're down to 114. Anything lower than 114 is very, very unusual. So I could have probably, and let's try it here real quick. We'll try it with our calculator. Somebody put this in their calculator.
I did already.
You got what?
0.4207.
4207. Now let's do this. The only reason I use negative 10,000 is because it's always going to work no matter what our graph is. Here we know that if we're down below 114, it's probably very unusual. So I could probably put in like 100, positive 100. Somebody put this in their calculator.
You mean negative 100?
No, just positive.
Oh, I see.
Because we're just saying, okay, if we're down past this, if we're down at 100, it's going to be a very, very unusual score. We should get basically that same thing.
Yeah. Basically.
What did it come up to?
420.
426?
No, 426. Yeah, sorry.
So it's really, really close to being the same thing. It's like a 10,000th off. So in I just use negative 10,000 because that's going to work for every problem that we do, and we don't have to worry about how low we should actually go on each problem. Or positive 10,000 if we're going the other way, because we know that that's going to be way out there. Now, if let's say we're doing some problem, and the mean is 252,000, well, then we're probably not going to be able to use negative 10,000 down here, because if the mean's that big and our standard deviation might be like 50,000, we're going to be way down or way up at some point, and we might need to change up our number. But for most of the stuff that we do, that's going to be good enough. Again, here, draw the picture. You can use a calculator, but you want to make sure that you have some idea. Like right here, I know if I was at 174, if I was finding the area from 174 down, what percentage should I be at? From 174 down, if that's the mean. 50%, right? So when I get my answer, looking at my picture, my answer should be less than 50%. Was our answer less than 50%? Yeah. So you can sort of just check to make sure you're in the right ballpark. Want to see another one, something like that? One going the other way or something? In between, so like 5. So problem 5 says probability that you go from 160 to 170. Again, I'm going to draw my little graph here. Just a little curve. 174 is there. 160 would be somewhere about in here. 170 would be somewhere about in here. So we're looking for that area right there. Anybody have a guess about how much area should that be, you think? Maybe 30%, something like that? So 0.3, we should be somewhere in that range. Should it be 0.8? That's way too much, right? That's a small area. That 0.8 would be almost the whole thing. So we should be somewhere in that range when we stick it into our calculator. Or you could use your chart still. Here, this time, when we stick it into the calculator, we don't need that negative 10,000 because we're stopping at 160. So our low limit is going to be 160. Our high limit is 170. Our mean was 174. And our standard deviation was 20. So we put all 4 of those into the calculator. What's that give us? 187.
1787.
So that would be our answer. A little less than 20%. That's the probability that, let's say these are test scores for whatever. I don't remember what it said it was for. But if these are test scores, the probability that somebody scores between 160 and 170 is going to be about 18% of the time. Other questions? Camden's got none. You understand them all, Camden? Malachi understands them now. Make sure you understand the first section too that we went over last time. Or that I guess you were you here for?
Not last
I
class.
have not been here since break.
Oh, wow.
I'm trying to think. Yeah, so you wouldn't have been here for that first one either. Other questions? Everybody can handle that. Again, the stuff that we do today, sort of like this, except it's going to be a little more difficult because you actually have to do some work. You can't just let the calculator do all the work. What we're going to do today, now I'm just going to explain this sort of an overview right now, is we're going to be given an area. Let's say we want the top 15%. We're gonna, you guys will be going off to college, and what colleges do is they have you take entrance tests, and on those entrance tests, what they do, entrance tests, what they do is they put their grades like this, and the top 15% of the students, let's say it's for a math class, they say, okay, the top 15% is gonna go to Calc 2. Then the next 15% is gonna go to Calc 1. Then the next 15% might go to college math, whatever it might be. So they separate it that way. Well, they want to know what score is right here to show where that top 15% is. So now instead of them giving us the score, we're going to be finding that score. They're going to give us the percentage or the probability or whatever, and we're going to be finding the score that corresponds to that. So it's like we're doing all this, but we're doing it backwards. So normal distributions, but we're finding the values. So normal distributions, find the values. We're going to find the z-score given the area under a normal curve. Transform that z-score into an x value. Remember, your x value, your z-score is your standard. That's your standard numbers. Everything that we change to a z-score is just in a standard form. The x values are your raw scores. You go to take the ACT, SAT, whatever, they will grade your test, and then you get back, let's say you're taking the ACT, you get back that you got a 22. All right? So if you get back you got a 22, that's not the actual score, that's not the raw score, that's the score that they've changed to some standard score. It's not a z-score, but it's a standard score, so that they can compare your score to everybody else's. Be able to find the specific data of a normal distribution given the probabilities, same idea. So, we were given in section 5.2, we were given, sorry, I gotta put this up here because it's annoying me. We were given the normally distributed random variable x and asked to find the probability. Now what we're going to do is go backwards from that. So we're just doing the reverse. So here, before we were starting with x, change it to z, finding the probability. And we didn't even change it to z most of the time. We just used our calculator to jump from here to there. Now we're going from here to there. The bad thing with this is sometimes you'll have to change it to that z to be able to find this. To find the z-score given with a given area, determine the cumulative area. What's cumulative mean again?
Add it up.
Add it up, all of them add up. So determine all the area to the left. If you don't remember which one's your left, Michael, you can always ask your neighbor, all right? Just say, which one's your left? Or look at Katie, she writes with her right hand. She writes with her right hand, so if you see her writing, you'll know that the other hand is her left.
Where did they hear?
Be able to use the chart to find the area. We're going to have to, I don't want to say we're going to have to, but some of the times it's going to be easier to use the chart. So that chart that I passed out a while back, you might want to make sure you have it. I don't know if you got one of these or not. Maybe you don't. So we're going to use this chart on some of these. And it's probably going to be easier to use the chart than it is to use the calculator on some of them. find the z-score. All you're doing is using the chart backwards. So instead of going down the sides of the charts here, we're going to search through the chart and we're going to find the area and then match it up to see what the z-score is. And we'll do a couple of them here in a second. Show you how to do that. So if you have that chart laying there, you might want to get it out. If you have it in your notes or somewhere. It's the standard normal distribution chart. So find the z-score that corresponds to the cumulative area of, and so we're looking at this area right here. All you're going to do is you're going to take your chart. Notice on your chart, it's got a positive and a negative side. What kind of numbers are on the, or where's the cutoff between positive and negative on the z-scores? If I'm looking at my graph,
1, -1.
the cutoff is right here at 0, right? What percent is on this side of that 0?
50.
50%, or 0.5. What percent's on that side?
45.
50 again, right? The cutoff is going to be at, for the areas, is 0.5. We want 0.5. Anything over here is going to be like 0.6, 0.7, 0.8, 0.9, because we're always looking at area to the left. So when we're looking here, that's going to be on this side of 0, so we're going to be in the negatives. So we want to be on the negative side. And that, if you don't figure that out, you'll figure it out when you start looking at the numbers and you say, oh, no, these numbers are small enough, so I need to go over to the other side. We try to find that number, 0.3632, in the chart right here. Anybody see it anywhere in there? So it's right here, 0.3632. It's negative 0.3. Is that right?
Yeah.
And then we match it up with the top up here. Negative 0.3. What's up at the top?
105.
If we go here, the score is right there. So we got negative 0.3, and then we're just going to take whatever number's up here. So it just gets a 5. That's our z-score. Negative 0.35 is our z-score for that area. Maybe they'll do a better job here. We have that. That's our area we're looking. Area to the left of that. Might be helpful to draw it again. I didn't draw it this time, probably should have. We look on the chart. On our chart, watch my little movement here. It's right there. We match it up. We look back here. That gives us the first part of our answer. We look up here. That gives us the second part of our answer. So negative 0.35.
Do you by chance have an extra chart? I can find on my old charts, I just can't find this chart. Thank you.
Now I probably lost it.
Yeah, probably. You're right, probably.
Now, if, this is where it gets harder. This is where you actually have to do something that the chart can't do for you. If we're trying to find z-score that has 10.75% of the distribution's area to the right. So we want this, we got our little graph here. We want to be somewhere about in here where this area to the right is 10.75%. So we're looking at this area. Well, the chart only tells us areas to the left. So what we got to do is we got to figure out what that area to the left is. And the way we're going to do that is first change this into a decimal, so bump it over 2 places. So that's 0.1075. The way we're going to find this area over here is just take, how much is the whole chart? 100 or 1, right? So it's 1 minus 0.1075. Somebody do that for us. 8925. So that's that area right there. When we look on our chart, that's all the chart tells us is to the left. So we're looking for this z-score right here that has an area that's 0.8925 to the left of it. So look at your chart and you try to find 0.8925 on the chart. 0.8925, is that going to be on the positive side or the negative side? It's going to be on the positive, right? Because it's bigger than 50%. 0.8925. 1.2. So we look at the chart here, it's 1.2. And we go over to right there, and it's got a 4. Malachi, you getting any of this? Shh. So that should be our z-score. That z-score right there is 1.24. Does it make sense for that z-score to be 1.24? 1.24, is that a high or low z-score? Sort of high, right? Well, if 89% of the data is below it, it should be sort of a high z-score. Let's try another one before I switch the slide here. Let's make up a decimal. Point, give me something. Point what? 321. So if we want, this is our number to the right. We're saying 32% of the data is to the right. So 0.321, the area is 0.321 over here. How are we going to figure out how much of the area is on the left? Somebody do that for me. 1 minus 0.321. This is why it's so important to draw your little picture here so you remember what you're looking for. What is it?
0.67.
And that's the number that we look up on the chart. So on the chart, let's find 0.679. Now, 0.679, since we've made a number up at random, is it probably going to be on the chart? Probably not. But we want whatever is closest to that. So 0.679.
0.68.
0.679, what is it? 0.6808. Is everybody looking at your chart?
Are we looking for 0.679?
We're looking for that, but it's probably not going to be on there. We want whatever's closest to it.
Yeah, 0.0681.
681?
Negative 1.4.
It's 0.
I'm so,
There's a 0.6.
I'm really confused actually.
Why are we what?
Where are we?
It's a
We're
three
trying to
number-
find-
Because it's the only way you can do it.
We're trying to find 0.679.
Yes. It's a
The
On
three
first
some
one
of
number.
these, yes.
0.5. 6.7. Unless I'm just crazy.
So again, let's go over it again. This is the area. We're looking for this z-score right here. All right? We're trying to figure out what's that score right there that gives us 0.321% or 0.321 of the area on the left or on the right. Well, our chart can't do that. Our chart only tells us to the left. So we had to subtract from 1 to get this area. Now on the chart, you're going to try to find 0.679.
See, I was confused because I didn't know there was a back to the chart, and I was like, the highest it goes is to like.
There's a 0.6772.
6772. Let's see if I can find that.
8.
So we got 0.6772, and we got 0.6808 is the one right next to that, right? Which one of those two is closest to this? Let's put a 0 on there. Maybe that'll make it easier for you.
6.8. For sure.
They're like the same away, I think.
Which one's the closest? One of them is closer. The top one? How could we figure out which one's closer?
Subtract it.
You could subtract them and find out, right? I'm hoping you don't have to do that. If you look at this, if you go from 90,
8.
790, 772, that's about 18 away, right? 790
48.
to 08 is how far away? Oh, so it is exactly the same. So we have to pick one that's right in the middle. Well, if we pick one that's right in the middle,
We could add 0.5 to the.
what we can add
or
0.5. We can add a 5 on the end of our answer, right? So what is our answer?
0.465.
0.46, and since we're going in the middle, we could just put a 5 on that. That's going to be our z-score. That's our z-score. Remember, this isn't a percentage anymore. You're actually finding the z-score. You're actually finding the z-score.
So where's the 5 coming from?
Since it was exactly in the middle of these two, we
One back?
we went to this one, and we did it was 0.46, right? And since we were exactly in the middle, this one down here would have been 0.47. Well, to be a little more precise, then we said 0.465, because that's exactly in the middle of those two scores. You just add an extra 5 on the end out there. So you just want to, now, if you put 0.46 or 0.47, you think I'm going to mark it wrong? I'd probably accept either one of those or that answer. I would hope that you get this answer, because that means you're thinking a little farther than what what was at just the bare minimum here. But I would probably accept any of those 3 answers there. So on the first one that we did, area to the right, notice they drew the graph there. Subtract it from 1. We look at our chart. That's the number we were looking for the first time when we did that first one. Come over to here, it's 1.2, and then we got the 0.04, so 1.24. Is that what we said the answer to the first one was? 1.24. So let's try this one. See if we can get that confused look off Ms. Clark's face. Find the z-score that has 96.16% of the area to the right. So we're looking at this. We want 96.16% of the area to the right. Where is my z-score going to fall at? I'm going to start over here. Tell me to stop when 96% of the area is to the right, where you think the z-score might be. Stop right there.
To the right?
To the right.
Keep going.
96% to the right. So do I stop here?
No, it's like.
Yeah.
About there, maybe?
Yeah.
Is that close? So when we're looking at this, we're looking at the area that's over here. We want 96% of it to be on that side. That's why we draw the little graph, so we can figure that out. Let's just make a guess at the z-score. Should this be a positive or a negative z-score?
Negative.
It better be a negative, right? Not only is it going to be a negative, but if 96% of the data is going to be to the right of it, it's probably going to be sort of a low z-score, right? And our z-scores go from +3 down to -3. They can go lower than that, but that's our normal range. So make a guess. What do you think it's going to be?
-3.
-3 maybe? Michael started to say -2 point something maybe? 2.8? Something like that? Somewhere in that range probably. So we now know that that's about what our z-score should be. Again, we can't use this. The area under the curve right here is 0.9616. We can't use that because our chart doesn't tell us anything about that. Our chart tells us what's to the left. How are we going to figure out what this area over here is? Subtract that from 1. So somebody do that for me.
0.0384.
384.
Yes.
Now we're going to use the chart. Are we going to be on the positive side or the negative side? So I got to flip mine over on the negative side, and I'm looking for that number, 0.0384.
It's -1.7.
0384. It's on there, isn't it? So it's -1.7. What? What's our next number? Go up to the top,
7.
7. That's our Z-score. So we were quite a bit off on our guesses, weren't we?
How did they come up with the chart then?
Because they went through and they figured all this out and then just wrote it in a chart. Just like on, if you remember back to geometry, I gave you a chart that had all the trig ratios on it, sine, cosine, and tangent. They just went through and they figured them all out and wrote them in the chart so you wouldn't have to.
So, if the number's not on here, it's probably not right.
Now, if the number's not on there, then you estimate it to the closest thing, because not every number's on the chart. That'd be too big a chart, and we'll be searching for days trying to find it, if we had every possible number. On this one, a little tougher on this one, we're trying to find between. So we're trying to find the, between two Z-scores. It's going to be a negative and a positive. When we're doing this, you really got to stop and think, all right? So as I'm showing you how to do this, this is the hardest one. This is the one you're going to have the most trouble with. We want Z-scores. We want a negative Z-score down here. We want a positive Z-score here. And those two numbers are going to be the same. So if this is 5, that's got to be 5. If this is 1.7, negative 1.7, that's got to be positive 1.7. Does everybody understand that part? Your two Z, the Z's are going to be the same. So it's going to be negative 2.3 and positive 2.3. 0.85, negative 0.85 and positive 0.85.
Is it just taking 95, well, taking 1 minus the 0.95?
We want 95% in here, right?
Yeah.
Now, we got to take 1 minus that 95%.
Then divide that into by 2.
Exactly. So you got to take 1 minus that. What's 1 minus 95%?
0.05.
0.05. Divide that by 2.
0.025.
0.025. 0.025. So what part of the area should be on each end here? 0.025. All we really care about is this one right here, because once we find that one, if we figure out that this Z-score right here is negative 1.7, well, what's this one over here going to be? Positive 1.7. So all we really care about is this end right here, and our chart tells us that. All we're going to look up is that area right there, 0.02, 0.025. So on our chart, is that going to be on the positive or negative side? Negative. So look up 0.025 or something somewhere close to that.
It's negative 1.96.
Negative 1.96.
Yeah.
So that's this one right here, negative 1.96. Well, what's this one over here going to be? What's this Z-score? Positive 1.96. So our Z-scores, the way I would write them,
So they're always going to be like,
they're always going to match up. The way I would write them is Z equals plus or minus 1.96. I don't want to say they're always going to be that way, but for the problems that we're going to do right now, that's the way that they're going to be.
Oh, we should have to.
So we're finding between those two pieces of data, 95% should fall in that range. So I lied to you, Miss Clark. Go ahead, write this down.
That happened.
I've never ever lied to you before, though.
There's no
does everybody use a calculator?
This is how to use a calculator. Now, I didn't completely lie to Ms. Clark, because can you use a calculator on every single one of these? Yes, but you have to do some thinking before you use a calculator. You have to know how to do it, otherwise you're not going to be able to plug the stuff into the calculator correctly. So if you get your calculator out, we'll go through and we'll do a problem or two, and I'm going to show you that even though you can use your calculator, sometimes it's more trouble to use the calculator because using that chart wasn't really all that difficult. So sometimes it might be easier to use the chart. So if we, let's pick, give me a percentage.
14%.
14% I heard. So if we want,
Flat 14.
if we want 14% of the data to be to the left, we're saying 14% of the data is down here. We're looking for what score is going to put us at that. What z-score is going to put us where 14% is to the left. If we're looking to the left, then you can use this because it's the same as the chart. What's in the calculator is the same as this chart. It just tells you what's to the left every single time. That makes sense? So on my calculator, so you might want to, for this, you might want to put down if to left. So if I punch it in, I hit second, vars, go down to, on this calculator, it's the number 3. I don't know what it is on all the calculators. Under vars, it's the third one. It's inverse normal. Inverse normal. So in other words, you're telling the calculator to do the normal distribution, but we want to do the inverse. So instead of knowing the z-score, we're finding the z-score. You're telling it to do it backwards. So second vars, go down to that. Then you're going to put in your area. What was the area that we picked?
14.
Now, did we put in 14? You put in 0.14. You got to change it to a decimal. And that's all you have to put in. Close the parenthesis, hit enter. What's it tell us our z-score is?
Negative 1.08031.
If we go to our chart and we try to find 0.14 on the chart. So if I'm looking on the chart, we want 0.14. Let's see, there's 0.103, so that's getting close. There's 0.1401, so that's real close right there, right? So it's negative 1.08. So did we get the same answer? Yeah. Now, if we're doing it where we have to go, let's say, we'll use the same 14%, but we want 14% to the right. If we want to go to the right, now what we still have to do is we got to change that to 0.14. That's the area under that part of the curve. We can't just punch that into the calculator because it's going to give us this answer again. So what we got to do is we still have to find that area. How do we find this area over here? So somebody do that for me. 1 minus 0.14.
6 or something.
0.86. Now we can take that number and stick it into that. I'm going to use my chart here and we'll see if we get the same answer. 0.86.
1.08.
You got 1.08. 0.86. See on my chart here. Give me a second. 0.868686. I got 0.8599 is probably as close as we're going to get to 0.86. And I get 1.08. Is that what you guys got? And that's a positive. Notice what was true.
Right?
It was the same. They were opposites of each other. Right? You were right. They're opposites of each other. Same number, opposite signs because we wanted 14% to the left, 14% to the right. Now, if we wanted to go in between, this is the harder one, especially trying to use your calculator. say we wanted 14% over here, 14%, I shouldn't say this one's harder, because it's not really. We want 14% on each end. So how much is gonna be in here?
72.
72, everybody agree with that? So 0.72 is in here.
Wow.
All we really have to do on that is find this z-score, and what do we know about this one over here? It's gonna be the positive of that one. So, and we already found both those, so this one's gonna be negative 1.08, and this one's gonna be positive 1.08. But you could still use your calculator to find this z-score, then just transfer it to be the positive of that. Same thing as you did up here, because all we're really looking for, since both these numbers are the same on the two ends, we find this z-score, and we know this one's just gonna be the opposite of that, so you do the same thing that we did up here. Alright, going back to a couple of things, percentiles, I'll give you a second to write a little bit of this down. It's been a while since we did percentiles. What's a percentile again?
Area.
It's a percent of what?
Tile.
Sort of. If I tell you scored in the 32nd percentile,
That means you were 32
There's like 10.
above or below.
32nd percentile, I'll explain it to you again. 32nd percentile means you scored higher than 32%. So if you're in the 32nd percentile, if we're looking at our normal curve, and you're in the 32nd percentile, you're at the 32nd percentile, that's P32, P30, does everybody remember that? Like P72 here? P32, you're in the 32nd percentile. That means this area down here below is how much of the area? 32%. So if we go to find that z-score that matches up to that, we're going to use 0.32 as our area to the left. So P72 means the 72nd percentile. Tells you that 72% of the data is below that X value, that score. And if we're looking for the z-score that matches up to that, all we're going to do, we can, again, take the chart or we can take the calculator. I'm going to take the calculator this time. I'm going to hit second, vars, inverse. What's the area down this way? 0.72. So that's all I have to put in this time is 0.72. Hit enter, and I come up with the z-score for that point, or for that right there, is going to be 0.5828. That's the z-score. Does it make sense for the z-score to be a positive 0.5828? Yeah, it should be higher than the mean, which would be right in the middle there at 50%, so makes sense. So percentiles again, somebody read this to me. P24, 24th percentile.
I'll find it.
All right, so make sure you remember what those mean. Probably another symbols test coming up here pretty soon. Find the z-score that corresponds to P5. So if I draw my little graph here, where is P5 going to be at? Tell me to stop when I'm at P5, or where you think it's close.
You got 100 now? Like, out of the 100?
Yeah. There?
There you go.
Because we want what?
5%.
We want 5% of the area to be below that. Alright? So, and do we even care about what this percentage is now? No, if we're looking at that, we're just trying to find that z-score so we could take our calculator. Gotta reset these calculators. And we just hit second, bars, inverse, norm, punch in, what do I punch in? 0.05. If you punch in 0.5, where's it gonna put you at?
Yeah.
50%, it's gonna put you right there. And I came up with
Negative 1.6.
something like that. So we're probably a little farther down than we should be. We should be back up this way just a little bit because we look like we stopped at about -3 or something. We stopped way out there. So we did that. -1.65, that's about what we said. Find each z-score. Let's just do one of these real quick. What's the z-score going to be for P at 50? Z-score. What's at 50? That's the mean, right? So for a z-score, that's, you got to know that. You got to know that percentile 50 is right at the mean, and on z-scores, it's 0.
1.28.
The next one's 1.28.
1.28. Negative 1.28.
That's -1.28. So on, so on, so on.
Negative.
Can use a calculator, can use a chart, be able to change those percentiles into z-scores. Write this down. I'll give you a second to write this down. You already have this formula, but might be a good idea to write it down again. If we're changing from X to Z, that means raw scores to standard scores. This is what we did. To change from Z to X, this is what we did. I know Camden's got those memorized already. He doesn't need to write those formulas down. Looked at him, he's got that
That's what I was thinking.
photographic memory. It's not photographic, what is it called? It's something like that, but it's not photographic, that's,
But if you're like, if you saw this and that's a photographic memory, you memorize every.
no, it's something else. Everybody calls it photographic memory, but it's not. The actual word is.
Dictionary? Fun game.
Brendan, you see what happens when you're out a couple of days. Can't get Malachi to not say silly stuff.
What?
You're off the tag, bro.
What is bugging me?
Huh?
He said, somebody said, try to turn to YouTube, and I was like, time. YouTube,
Two 52 was. Will somebody give Brendan the 252 assignment?
Yeah.
Tell him what it is before we leave today.
Here, bro. Copy it.
Like the Canada.
I write this down, and sit the homework out.
Do what?
Homework?
You have to make into a.
Ready for homework?
Do we have any? Oh, shit.
So if we're changing it, if we're trying to find the raw score, and this is important because sometimes you don't want to know what the z-score is. All right? I tell you guys your test score and I give you z-scores every time. That's probably not going to make a whole lot of sense to you. You want to know, hey, what was my percentage on that test? So if we were going from z-scores to raw scores, as a matter of fact, next test we might do that. I'm going to put z-scores on your paper, and you're going to have to change them back to raw scores. And I'll add points back to your test if you get it right,
Good.
what your percentage is.
Good.
All right, so to do that, we're going to do this. What's mu stand for? Mean, z,
Score.
z-score, stupid thing. And then sigma stands for standard deviation. So that's all you're going to do to switch it back to a raw score.
U plus Z.
So let's try one of these. No, don't do that. A veterinarian records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weights X corresponding, find the weights X, comma, there's supposed to be a comma in there, corresponding to the Z-scores 1.96, negative 0.44, and 0. So the first one, 1.96. We got these cats, my curve's not very good. We're at 1.96 right here. We want to figure out what weight that is. If that's a Z-score, that's our Z-score right there. So all we're going to do is we're going to take that Z-score and we're going to change it back. What was that formula again? Because I forgot it already. X equals what?
Plus Z times, standard.
Medium motivation.
So we're looking for the X value. We're looking for how, first of all, this cat, is this cat going to be fat or skinny? Fat, because he's on the positive side. What's our mu? What's our Z-score? What's our sigma?
2.
Somebody do all that math for me real quick.
12.92.
12.92? So what's the size of that first cat?
Humongous.
12.92 pounds. Like one of my stupid
Is
cats.
that even, that's not even big.
Yeah, for a cat, that's big.
I'm pretty sure I had a cat that was like 18 pounds. It was fat.
I
And
thought
then it
cat
lost
weighed- I
weight.
thought cat weighed like 30.
It lost weight and it has like flat like everything now.
The next cat.
And the only one left here.
Next cat has a Z-score of negative 0.44. So that's going to be negative 0.44. The mean's right there. That's going to be somewhere like right in there. Is that cat going to be
Skin.
fat or skinny?
He ate
It'd
fat.
probably be about normal, wouldn't it? It's because it should fall within a range from -1 to 1 would probably be normal. All right, so this cat's probably fairly normal. And that's probably what the vet looks at. They go, from -1 Z-score to 1 Z-score. And if your cat's falling in that range right there, they say, hey, your cat's pretty normal. If your cat's above that, you might want to put your cat on a little bit of a diet. Cat's below that, he's probably going to ask you, are you actually feeding this cat or what are you doing? You being cruel to the poor animal like I am to my cats? I'd rather they didn't eat.
You have a cat.
3 of them, and they all need to go.
What are their names?
Dumb, dumb, and dumber.
What are their real names?
I
You have two
don't
that
have a
same as
clue
dumb?
because I don't like them.
So how do you tell the difference between dumb and dumb?
I don't tell the difference between any of them because I don't see them for long enough because I see them, they see me,
They
they run. And if they don't see me, they feel me real quickly after
You-
that.
You hear them run.
Because they get that. Because one of them's a male cat, and he thinks he's big and tough, so he'll every now and then he'll press his luck and he'll see me and he'll just sit there like, yeah, I see you.
Guaranteed
And then
he's
I
not gonna shake his head.
Did you see me now? And then he's running.
Poor cat.
Not a poor cat. Ignorant cats. Make my house smell bad, cost me money,
Throw 'em outside.
food. I do all the time. Guess what happens?
Take them back.
My
Yeah.
family lets them back in. When it was real cold that one day, a week ago,
You gonna freeze them.
they're out there.
I
Well,
would-
they were only out there a couple minutes. They got fur.
I would throw them out like bacon.
Negative 7.
Well, let me take that back because I don't throw them out because the male cat wants outside.
Oh, Okay,
So,
that's a
so
different
soon as
story.
that's the only time he gets close to me, is if I'm going to the door, he runs to the door, cause he knows I'll let him out. Cause I want him to go out, and I want him to stay out, I want him to go out and find something in the woods, and not be able to find his way back. So I let him out. Well, that day, I opened up the door, and he ran right to the door, and I said, "You're stupid." And I let him run out. About 2 minutes being out there, he was freezing to death, and he's following me all around, meowing, because he wants back in the house. So we do this. We're going to do the same thing. X
What were
score.
you doing outside?
I was probably working in the barn, working on the barn. Our mu again stays 9. Our z-score this time is negative 0.44. And our standard deviation's 2. Somebody figure that out for me real quick. 8.12 pounds. Now,
Why did it split in the middle? Like how do you know?
I didn't. I said it should have just been right here. But I said the vet probably looks at from -1 to 1 and says, okay, that's about normal. If we didn't want this score like this, because that really doesn't tell somebody a whole lot, if you're saying, yeah, your cat's about 8.12 pounds. Because you probably say 8 pounds and so many ounces, right? The way we could change that to make it look a little more sensible, we know it's going to be 8 pounds, but how many ounces do we have there? Do we just have 12 ounces?
How many ounces are in a pound?
120.
How many ounces are in a pound?
Like 16.
16. So all you do on your calculator, you take that 0.12 and you times it by 16. So somebody do that for us real quick. What's 0.12 times 16?
1.9.
So we'll say about 2. So about 8 pounds, 2 ounces is about what that cat weighs. That would make more sense to the person that you're dealing with.
You say you weighed 8 back?
The next one, if we want a z-score of 0, and I'm hoping you don't even have to plug into this formula for this. If your z-score is 0, what's your cat going to weigh?
0.
No,
50.
9 pounds. How'd you get that?
Is 9 is
9 is the mean. So if the z-score is 0, it's right at the mean.
Maybe your cat wasn't born yet. He doesn't weigh.
Then you wouldn't have a z-score of 0. To find the specific data, this is what we just did. Draw the graph, find the percentile. Remember, the chart shows to the left. Or no, this isn't what we did. We just changed them over. Use the formula to find the x score. We could do that. Probably don't need to write this down. You've seen how to do it. It's not that difficult. You can, I'm going to skip over this. You can use the calculators to find this stuff. This is how. So if we're actually looking for, let me move this. No. If we're actually looking for an x value, so we're trying to change it from a z-score to an x value, we can do this. Or if we want our answer to be an x value, this is what we use. This time you got to put in 3 things. You got to put in the area, you got to put in the mean, and you got to put in the standard deviation. So you're doing the same setup, the inverse normal, but you got to punch in 3 things separated by commas instead. Now I should go back. Usually I don't kick those cats. I usually squirt them. I have a squirt gun I carry around the house. I squirt them with the squirt gun. I'm not quite that mean, but
You probably have a liquor.
I just have a little squirt gun.
You have an airsoft gun you shoot
I
at.
paid like $1 for it or something, and it lays full around the house, and I squirt them
Did
every
they
time.
jump up on you?
They don't jump up on me.
He chases the cat through the house and screams.
Why do you chase the cat?
I was in the living room watching TV, he comes in there sneaking.
Because it was funny.
It was not doing anything, all I just you're there.
He was doing something, and I made sure I caught him.
What was he
So he
doing?
sort of understood it. He was in the kitchen, and he was, getting into stuff that he shouldn't have been getting into,
A
so.
cat?
Huh.
And the male, he likes to jump up on the tables and the counters and stuff and that.
All cats do that.
Yeah,
Well, they like higher up places, so that,
he
Private
knows,
cat tree.
because when
I was gonna say, get him like the little, things you can
that's
install
more
in the
money I'm
wall.
spending on a cat that I don't even want in my house.
Well, then it won't come under tables.
Yes, he will.
I don't think so.
You can tell that he still would. I mean, he's just you can tell he's a jerk, because you walk out the door and you watch through the window, and what's the first thing he does? He goes and does something like jumps on the table, because he knows he's not a dumb cat. I'll give him that. But I've watched him, and I think that day that's why I was chasing him, because he jumped up on something and he thought, he seen me and he thought, oh crap, and so he took off running. So if we were looking at, what was that one cat that they had, what was it, 1.96, is that what the Z-score was?
Have you ever fell chasing one?
If I ever fell?
You tripped over something?
Yes, I'm just so fat and uncoordinated
Did not
that
fit.
that's what I
Said
did.
that yourself.
So if I do this for 1.96, the Z-score of 1.96, we can't use the calculator unless we do what with that? We got to find what first?
The other part.
We got to find the area. So you can't punch it into the calculator just using this. So we need the area that's going to fall from there down at 1.96. Now, could we use this to find that area? Yeah, it might be easier to use the chart to find the area. If I look at 1.96, 1.96 is right here. Looks like 0.9750. So it's pretty easy to use the chart to find that area, or you could use the calculator to find the area like we did last class and punch it in that way. Either one of those ways would work. So we're going to hit second, bars, go down to inverse norm, and we're going to punch in the 0.9750, comma, our mean. What was our mean? 9? Is that what it was? 9 pounds? And then our standard deviation was 2. Close the parenthesis. And we get 12.91. Is that what we got the other way? That's not what we got the other way, was it? 12.9?
12.96.
Something, it was close to that. It was about 12 pounds?
Yeah.
More than 12 pounds?
It was a heavy cat.
Okay. So that cat would weigh about 12.9 pounds. Braking distances for Nissan Altimas are normally distributed and have a mean of 129 feet. We're probably not going to do all this. You got to be able to sketch the graph. So sketch your graph and figure out what you're looking at, whether you're looking at stuff to the left, stuff to the right, stuff in between. Find the Z-score, find the X value, be able to explain your results. Again, you can use your calculator on this, so you might not have to find each value.
Lucas responded.
The other day before?
What did he say?
He said, I'll knock it out this weekend.
That's your